You're welcome to the Scholar School. We establish our footprints on the sand of time. Experience the difference.
Welcome to class. Today we are doing equations of motion, and there are some certain things we need to introduce ourselves to. Now, earlier before the equations of motion, we have motion. Just to bring down balance, that is why we are introducing equations of motion. Now, motion is the effect of when a force is applied to any particle. For example, we could have a car. When a car hits a car that is stationary, the car begins to what? To move. That means a force is applied to the car to make it what? Move. But the force that was applied to the car, which is another car, is already in what? In motion. It's a car that is not in motion to what? To produce motion. So we are just taking that into what? Into consideration. Now, we have four equations of motion. How many? Four equations of motion. Average average now we have this. Okay. Sorry. First one. We have the first one to be V equals to U plus AT. We have the first one to be V equals to U plus AT, where our V is representing my final velocity and my U representing the initial velocity. My A is representing the acceleration and my T is representing my time. Then we have the second equations of motion, which is V squared equals to U squared plus 2AS. Now, my U is still initial velocity, V final velocity, A is my acceleration, but this S is not talking about my distance. Are we getting this thing at all? Then we have another one, which is V squared equals to UT plus half AT squared. We have V squared equals to UT plus half AT squared. Now, my V is still my final velocity, my U initial velocity, my T time, my A my acceleration, then my T is still my time. Then we have the last one, which is S equals to V plus U over 2 times T. My S, which is my what? My distance, equals to V plus U over 2 times T. These are the four equations of motion that we have, and they all have force. They all have force. Now, there are ways of using these equations of motion. We can't use them at once. It's a question that will tell us when to use our first equation. It's a question that will tell us when and where to use our second equation, fourth, third, or anyone. Now, let us solve our first example here. We have the third equations of motion, which is our S to be equals to UT plus half AT squared. And our last equation of motion to be our S to be equals to V plus U over 2 times T. And all these equations of motion has applications. Now, to know when to apply them is when you check your parameters and notice the parameters are included in any of these formulas. All you just need to do is to write out the formula, then you substitute for them. Now, let us start with example 1. Now, for my example 1 here, I have a question, a wire question here. It says a body accelerates uniformly from rest at the rate of 3 meters per second for 8 seconds. Calculate the distance covered. Calculate the distance covered. Now, take a look at this. We have a question. The question says a body accelerates uniformly from rest at the rate of 3 meters per second for 8 seconds. Calculate the distance covered by the body. Calculate the distance covered by the body. Now here, check it very well. The step number 1 is to be able to identify your parameters. Now it says a body accelerates uniformly from rest. That means the body is what? Is stationary. Then what is the initial velocity? That's what? 0. That means our u is equal to what? 0 meter per second. Now that says at the rate of 3 meter per second. That means the final velocity is what? 3 meter per second. That's what? V equals 3 meter per second for 8 seconds. That means our time is equal to what? 8 seconds. Then the question says what? Find the distance covered. Find the distance covered. Now let us check very well. To find the distance covered, that means you want us to find what? Our s. You want us to find what? Our s. Now can we check very well? Is there any way we can use s here without we having our acceleration, our time, our acceleration and our distance we are looking for? We have a formula we can use here, and we can still use this too. Now let us use this, then we use this method. Now how can we use this? We have acceleration, and acceleration is what? Change in velocity over time. Acceleration is change in velocity. That is v minus u over what? Time. What is my velocity? That is my final velocity, which is what? 3. Minus what's my initial velocity? 0. Over what's my time? 8. So we have what? 3 over 8. This is my what? Acceleration. Now if I'm not using my acceleration, which is meter per second squared, if I'm not using my acceleration, I can just go straight to use this. But let me find my distance using this, substitute it here, then my answer I put it somewhere, then I use the same formula to probably check if probably the answer is right. Now let us prove it. Now if my s is equals to ut plus half at squared. Now what is my u? 0. So I have 0 times what is my time? 8 plus 1 over 2. What's my acceleration? 3 over 8 times what's my time? That's what? 8. So I have what? 8 squared. Are we getting this at all? Now 8 squared here means 8 times 8. So this eliminates this. So I have what? My s to be equals to 8 times 0. That's what? 0. That's gone. So I have what? 1 over 2 times 3 over 1 times what? Times 8. Here 2 eliminates what? The 8 here I have what? 4. 4 times 3, that's what? 12. So I have what? 12 meter. For my what? For my distance. Now let us use the second alternative. Since my s is equal to what? V plus u over 2 times t. Now what is my v? My velocity. That is my final velocity, which is what? 3. Plus what's my initial velocity? 0 over what? 2 times what's my time? 8. So I have what? 3 plus 0, that is 3 over 2 times what? Times 8. 2 here what? 1. 2 in 8, 4. 4 times 3, 12 meter. Are they equivalent? Yes. So this is how to find what? The distance. This is how to answer the question. That means we can just derive formulas, then we are good to go. Now, if I want to solve the question, I can just make use of this alternative, but it's not that long. Yes. Then I might also use this one, find my acceleration, then find my what? My distance. Are you getting this in at all? Now let us solve example 2. We have a question here for after the equations of motion. Now, this is how to apply them. We have a body accelerates from rest at the rate of 3 meters per second square. Because 3 meters per second square is for acceleration. That means our acceleration is given to what? 3 meters per second square. Now, it says a body accelerates from rest. That means the initial velocity u is equal to what? 0 meter per what? Per second. Then we have for 8 seconds. That means our time is equal to what? 8 seconds. The question now says what? Find what? The distance, which is what? Our s. And we have in the equations of motion that our s is equal to ut plus half at squared. That means we can use this to what? To get our what? Our distance. So we have our s to be, what's my u? That is 0. So I have 0 times what? Times 8 plus half, what's my acceleration? That's what? 3 times t squared, that's what? 8 squared. 0 times 8, that gives me what? My 0. So I have s to the equals what? Half. That is what? 3 over 2 times 8 times 8, that is what? 64. So I have my 3 over 2 times, 2 here 1, 2 in 64, that is 32. So here I have what? 3 over 1 times 32. So 3 times 32, that is what? 96 meters. So this is how to solve this question. That means our answer here, which is the distance, is what? 96 meters. Now let us solve another example. Let us take a look at this. We have a question. It says the motion of an object moving in a straight line is uniformly retarded so that it comes to rest in 20 seconds after traveling a distance of 40 meters. Find the initial velocity. Now here they are not telling us that this body is already in what? In motion. Now we can only say that our initial velocity is 0 when the body is yet to be in what? In motion. But this body is already in motion. Now the initial velocity already has value and it is not what? 0. Are you getting this thing at all? The initial velocity here is what? Has a value. But we have our v, which is our what? Our final velocity. We have our v, which is the what? The final velocity. Now they say it is coming to what? To rest. That means the final velocity here now becomes what? 0 meter per second. That means the car has the driver has already what? Applied the what? The brake. The final velocity becomes what? 0. But the initial velocity becomes what? Unknown. Now they now said it travels a distance of what? 40 meters. That is what? S, which is what? 40 meters. Then here we now have the time. The time at which the of the travel to what? 20 seconds. Now the question says what? Find the initial velocity. There is a particular equation of motion that has all these parameters, which is what? S equals what? U plus V over what? 2 times T. Yes or no? Now, so that our S, which is what? 40 meters, is equivalent to what? What is my U? Unknown. U plus what is my V? 0 over what? 2 times what? What is my T? 20. Are we getting this at all? So that we have my 40 to be equal to what? U over 2 times what? 20. So that 2, we eliminate part of this 20, I have what? 10. So that I have 40 equals what? 10 U. What do? I divide all 2 by what? By 10. So that I have my U to be equals to what? 4. 4 what? Meter per seconds. And this is how to solve this question. That means the initial velocity of this body is what? 4 meter per second, and the final is now what? The 0. The distance covered is 40 meter and the time taken is what? 20 seconds. And this is how to solve this question. So we started with the equations of motion and we saw some examples using the equations of motion. The first key is to be able to identify these parameters. Where do they fit? What particular equation of motion can I insert them into? Now we saw the first one here. We have our acceleration, the initial velocity, the time, and we have to find the what? The distance. We know that a particular equation of motion says s equals to ut plus half at squared. We have u, we have t, we have our what? Our a. That means that equation is the best one that we can use. And likewise this example, we have our velocity, which is our final velocity v. We have our initial velocity, which is unknown. We also have our what? Our distance, which is 40 meters. And likewise our time, which is 20 seconds. The question says what? Find the initial velocity. We know there's a particular equation of motion which is applicable to solving this question, which is what? S equals u plus v over 2 times what? Times t. And we used it and we got our initial velocity to be what? 4 meter per second. And these are to solve questions using the what? Equations of motion. So thanks for watching.